So it's a pretty cool project that we have thrown together. We were able to actually create a computer vision model that could detect what type of plant this is, even though I have no idea what it is. So we even tricked the large language model and the vision model as well, because this is a fake plant, as you guys can see, so it doesn't need any water at all. Hey guys, welcome to a new video. In this video here, we're going to create an AI project from scratch. So we're going to combine a lot of different elements within AI. So both large language models, how we can use those, used open source models. We're going to run computer vision models. So for the project, we're basically just going to create this plant care project. So the only thing that you have to do is show your system a plant, and then it's going to extract information about it. And you can also just ask it, how often should I water this plant? It's going to give you a response extracted from the large language model. And the best thing is that we're going to run all of these models locally on our own computer, and we can set them up with just a few lines of code and some configuration. So for this video, we're going to use a platform called Viam. It's pretty cool. We're going to go over the platform with different features and so on, but you can use the platform for basically just integrating all of the things together. You just have your computer, you can set it up on your computer, also on like edge devices. So it could be Raspberry Pis, Jetson nanos, and so on. You're just going to set up a server that can communicate with their platform, where you can go in and do the setup in there. So we're going to use the VM platform to set everything up. I'm going to show you how easy it is to set up large language models, computer vision models. You can even train a computer vision model in there. And then you have pretty much deployed all your AI models, large language model, computer vision models, and you have a real world AI application up and running. So we're now jump straight into the VM platform. First of all, let's just go over some of the features that they have. Then we're going to show you how we can set it up locally. This can both be used for like MacBook, Linux systems. So basically, like if you have any edge devices, you can do this on the sideline on a Jetson Nano or like a Raspberry Pi or something like that. And you don't have to do anything else. You can do the exact same setups as I'm going to do right now, but I'm going to use my MacBook here that I'm recording on. So this is pretty easy. We can just go in and get started. We can take a look at the platforms. If you take a look at the products from Viam, they basically have like everything in there where you want to deploy like machine learning models into the real world. You don't need to write a lot of code. They have SDKs for all of it in different programming languages and so on. Now we actually just need to do the configurations, and all of these models will run locally. So no cloud, no deployment. It can run directly here on the VM platform. We just need to set up a server on our side that we can actually communicate back and forth. So every time you do an update, it will automatically update it and basically deploy it in your application and project. So first of all, here we're mainly going to focus on like the machine learning models, different components and services. So right now, let's just see how we can actually get started. Let's jump into the documentation. So they have the platform overview for the registry data. They also have like a bunch of different models. If you just want to test out some models, they have a registry where you can go in and find different models. So they do a lot of integrations with the platforms that we already know. So it could be like, for example, Roboflow or Hugging Face, which I'm also going to show you. So these are different platforms. We also have different use cases and so on. You can see all the solutions here that they're doing. You can do code deployment, data analytics, and so on, but we're mainly going to focus on computer vision, large language models, and how those can be connected together. So right now, let's go inside the documentation and let's just test it out. So this is also used for robotics, where you can basically like set up robotics arm, simulations. You can even like have these rovers. So this is how we take AI and machine learning into real world projects and actually like deploy them on robotics systems. So before we're going to do the setup, we can just go in here. You can try it out yourself. Just go into the VM platform, try out Viam. First of all, we need to click on try in Viam, reserve your slot, and then you can get started with Viam. So they actually have a robotics lab where you can get a physical robot assigned to you, so you can test out the control drives and also the programs that you're writing with this platform. So that's pretty cool. Definitely test that out. But right now, let's try to go in and see how we can do the installation on our own computer. So I'm going to use my MacBook Pro as mentioned before, but you can use any Linux operating system or Mac OS. You can also use these boards that we can see down at the bottom. So the Raspberry Pi, Jetson Nano, and all of these other ones down here, which are supporting these requirements up here at the top for installing our VM server. So our server is basically just going to communicate with the platform here. So you can do all the configurations in the website. So you can set up different projects, combine different services and also components. Then you can deploy the apps and they're running locally. So right now, let's go down to the install VM server. You can also see some Windows support here if you have WSL on your computer. So right now we're going to go for the Mac OS. We also have the Linux, but it's going to be pretty much the exact same steps that you need to do. So first of all, here for Mac OS, we need to install Homebrew. Then we need to go in and set up the app in Viam. But let's just go and take a look at the Linux tab here. So this is basically all you have to do. Just run them line for line here in the terminal, and it's going to set everything up. So this is basically just for the server, where on Mac OS we can use Brew to install that package. So now go into macOS. First of all, we have Homebrew. Go to the VM app and add a new machine by providing the name and new machine and so on. So these are pretty intuitive to do. So I can just go inside the VM app and probably just do it straight away. There we go. Let's now go and add a new machine. I just did one here above, but let's add a new machine. So let's call it YT for YouTube. We're going to add the machine and we're going to set it up with our configurations. So now we get our install instructions over here to the left. So install VM server on your Mac. Ensure that you have Homebrew installed. You can just directly go and install it from the documentation. After we've done that, we can copy it. We can open up a new terminal and we can just paste it in directly. There we go. It's going to brew install the VM server, which we can then run from some app configurations. And then we have everything. We can now communicate with our platform. So while it's downloading here, right now we can see that I already have it installed, but I have some outdated modules that need to be installed. So while it's downloading here, we can go over to the left and see that we need to download the VM app configuration to the Mac. So this is basically just the standard configuration file that you're using, but you can also do customizations to that. I just hit download and then it's going to download it here locally to my computer. So once we have installed VM server on our computer, either if you're using like an edge device or you're running this on your MacBook or a Windows system, then we just need to download this app configuration and we can start the server directly. Let's try to do that. Let's see if it's done installing it. So we'll just take a second or two. So now we can see that the VM server is done installing. We both have our app configuration as well. We can go down and copy paste this command to start a server directly. Right now I'm just going to paste it in, hit enter, and it should start the server here automatically. You don't need to do anything else. Once it has started the server here locally on our own machine, we can connect to it directly in here. So now we can see we got this green tab. Your machine is connected. Proceed to the configuration tab. So right now we can just directly go in here. Now we know that we have connection to our service, and then we can just go into our services and also components, add different components, set up some configurations, and then that's everything that we need to do. So for the components, if you just take a look at it, we can set up like robotics arm, base, board. So if you have specific boards that you're using, Jetson, Raspberry Pis and so on, set them up in here under the components. So the component that we need to start with for our project that we're building is a camera. So right now we can see that we have a bunch of different camera options in here, depending on if you have an RTSP camera, if you have a web camera and so on. They have all of these different kind of like configurations pre-built into the platform. So right now let's just go down and choose the webcam, which is pretty cool. So let's just call it webcam. And then we're going to create it, and then we can just reference these names that we have given our services, but also our components later on in code, and then have SDKs in multiple different languages. I'm going to use Python. So once we have added a new component or service, make sure that I go down and save the configuration. When the configuration is succeeded here, or like successful, it's going to set it up in here. So you can see that it's actually connecting to my camera. So we have a FaceTime HD camera, intrinsic unknown for the camera model. And then you can basically see that now you are connected. We have the platform connected to our server here that can interact with our local hardware. So right now we have this. We can go in and choose the video path here. So we have my cam link, FaceTime, and also my iPhone camera. Let's try to go with the FaceTime HD camera. So that should be the camera on my MacBook. Let's save the configuration, and we should be able to go into the terminal and actually go in and see that it starts to connect. I can see the green dot over here to the left. So now I actually have access to my MacBook camera. Again, if you have multiple cameras connected, you can have multiple components and so on. So if you guys don't believe that this is how easy it is to set up a camera and that I'm lying that this light here is actually like flashing green, let's go inside the control. So right now we're connecting directly from the platform to our server running locally. And now we can just toggle this on, view webcam, and we should be able to see the extractions over here. So now we have our camera. Now we can go back here to our setup again and our configuration, where we can add like multiple different components, but now we should go inside our services. So let's go in and create a service. So right now, again, they have integrations for Roboflow, Hawk and Face, if you find some vision models in there that you want to test out. So this is pretty easy. Also, I know a lot of you guys are interested in SLAM. So if you want to do simultaneously localization and mapping in your environment, they also have components for that. So we have Vision, SLAM, local services, machine learning models here. So you can deploy machine learning models directly. You can even train them in here on the VM platform. I'm going to show you that in just a second. So this is how easy it is. Let's now go down and use our Vision. So right now we can do color detection, machine learning model, obstacles, and so on. They also have a lot of registries that you can connect to. So face identification, object tracking, and so on. But we have this integration with Roboflow. You can also see that ULV5 and ULV8 from Ultralytics are deployed directly in here as well. But let's now go ahead and take this Roboflow Vision. We can add the module. Let's just call this plant model. There we go. Now we actually just have our Roboflow in here. We just need to set up some configuration in just a second. I'm going to show you the code snippet for that and also how we can extract a Roboflow model. If you just go inside Roboflow here, I have a bunch of different projects that you can go in and extract. But if you want a new model, you can go inside the universe. Let's just go in and type in plant detection. We hit enter, and now we should get a bunch of different examples in here. So if we just take a look at them, let's just try to go down and actually use this one. So right now we have a bunch of images here for this data set. We can see that we already have a model. So now we can just go in, connect to this model, directly integrate it. I'm going to show you the code snippet in just a second. So let's now go in and set up our configuration. The first thing that we need to set up is our API key. So API underscore key. And then we basically just need to paste in our API key here. I'm not going to show you guys that. You can directly get that from your Roboflow account and just paste it in here. And then you will be able to run this model directly as well if you just copy paste the exact same things as I have here. So we also need to set up the project. So that is called house plants image detection. So this is the project for our model, which is actually trained on Roboflow as well. And then we're going to set local equal to true. So this is just to specify that we want to run this model locally on our own computer and own hardware. And then we also need to set out the version. So this is the version from Roboflow directly. So if you have multiple different versions, could be because you have trained different models on different data sets with different augmentation steps and so on. You just need to specify it here. So this is everything that we need to do to be able to integrate with Roboflow. You guys are familiar with that. We have a bunch of videos here on the channel going over like how you can annotate images with Roboflow, train the models in there, and also just do a bunch of cool things and export the data set, set up the API keys and so on. So you guys are familiar with that. This is just to show you guys like how we can integrate all these platforms together and make these AI, machine learning models, computer vision models as easily to deploy as possible. So right now we should actually have everything. I can just set up my API key here. We can save the configuration. We can also set up the different components that this service depends on. So we can actually say that our vision model here will depend on the webcam, and then we can just save the configuration and we have our API key. It's going to extract that model from the Roboflow inference API, and then we can run that locally, extract the model, and then we're good to go. So right now I've just saved the project after adding my API key, and we can now see that it is loading this Roboflow project directly locally on our machine. Okay, so once we've done our whole setup, we can now go inside our code example. So we have a configuration set up. We can go inside the code example. And this is basically just a code example that you can throw in for the specific project that you're actually creating now. So we will have a webcam and we also have our vision model connected directly. If you add more services, components, and so on, it's going to generate this code example directly as well. So you can use it straight out of the box without writing any code at all. You just have to do these configurations on the platform. We both have Python, Golang, TypeScript, C++, Flutter, and also remotes here. So you can get code snippets for all of them. I'm going to use Python here, and we also have the Python documentation. First of all, you need to set up your own environment, and then you also need to pip install this Viam SDK or set it up in the other frameworks and programming languages that you have. So right now we can just directly throw it into our command prompt or our terminal, and then it's going to install everything for us. Once that is done, we can go down and copy paste the code snippet directly. So I've already done that, created a Python script from scratch. You can also include your API key up here at the top with the toggle, but I'm not going to do that in this video. So let's now just jump straight into the Python program. So first of all, we just need to import these different kinds of things. So from the VM RPC, robot, the services and so on that we're using. So both speech, chat, and so on that we're going to use later on. Then we're going to connect here to our robot client, set it up with our API key and also our API key ID and also the address that we are using. So this is the address that I'm using right now for connecting from my server to the platform, the VM platform, as we're doing our configurations into. So we can see that we have this YT here. So this is just the name of our project. So we have YT-main. So this is how we can do connection to our robot client and do everything for us. So now we're going to create our main function here. We're going to connect to our robot or like create an instance of it. So this is just what's going to handle all of it. From the vision client, we can set up a vision client from robot, and then we can just connect it together with our robot that we have connected from our local server. And then we can just specify which of the models that we want to use. So the model that we set up inside the VM platform, which is the one that we integrated from Roboflow. So now we have our Roboflow plants model directly here. This is a single line of code that you need to throw in, and you even get it directly from the code snippet. Then while true here, you're going to connect to the camera as well, because again, our model will now depend on the camera. We can get the detections, from camera, and then we just need to specify the name of the camera. So this is the webcam, or like the name that we specified once we created that component. Then we're just going to await here for getting our detections, and we will extract the detections in this variable. We can print the detections. If the length of the detections is greater than 0, we can print out the class name as well. So we can just delete this line. And then once we have a detection, it's just going to throw out the class name. Right now, we're just going to do basically just the detections directly from our web camera. We still have it connected over here to the left. Now we can go up, save our program, open a new terminal, and run it directly. So now we have a new terminal, Python test.py. And again, these models are running locally directly inside here. So I can just pull it over here from the left. Right now, it's just going to connect to everything. So we can see that it connected to the socket, and we have the server over here to the right. We can see the frames and so on. So now everything is up and running. Let's just pull up a plant here. I just have something right here. So right now we have a plant. This is what we're going to use. So I'm just going to put this in front of my webcam here to the left. So now we can see we get this monster, the Lycia. I'm not sure which plant this is, but it looks like it's getting that most of the time. Let's try to do some other plant later on when we actually have our full data set and our whole program up and running, but we can see we get our detections. If we just go back here again and just try to like print the whole detection, we will also get all the other values. So right now we can just print the detections, terminate our program, run it again, and this is how easily it is to run. So right now we can see we're just getting some empty list. So let's now pull this up in front of the camera. So we see that we get the class name, the confidence is here, and also our bounding boxes. So we have our X-min, Y-min, and also our X-max and Y-max. We get the class name, confidence score. So this is how we can extract the results from our object detection model directly from Roboflow. So while we're talking about like generating data sets, you can also do that directly with Viam. They have an app as well. You can go and upload images. Let's say that you just want to create like a quick data set, or like create a quick AI machine learning applications that you want to deploy directly. Take your phone, capture a bunch of images, upload them directly. They will be synchronized with your platform via. You can train the models in there, annotate them, do everything, deploy them directly with these configurations that I've shown now. And you can probably have like a whole machine learning computer vision project running in probably like 30 minutes just from starting out with your phone, capturing a bunch of images, and then you have solved a computer vision problem. So right now we're just inside my phone here. I've just captured a bunch of images. First of all, we just need to go inside home and then our first location. We now need to go into our YouTube. We can see that we're actually live with that. We can even connect to the camera in here, so we can see the camera feed directly in the app as well. So this is pretty cool. Right now we can go up into the 3 dots as well. We can upload images. So let's say that we have captured a bunch of images. So right now we just have these different ones, so we can add those. I'm just going to add a bunch of images, upload them to the platform, and then I'm going to show you we can use the annotation tool and also train our models in there. So now we have our images here. We can just go in, view the different images, and we hit go, and then it's going to upload the images to our platform. Just go inside our platform again. Let's try to go inside our data view, and we should be able to go in and see our files and images that we have uploaded. So right now we can see that we have 7 images, and these are just off my keyboard. So right now, if you just choose one of them, we'll get the view over here to the left, and we can go in and do annotations. So let's say that we want to do bounding boxes. We can go in and create a label. So right now we're just going to create a keyboard, and we can just directly go over and label that here with our bounding box. So we can actually just set that to the data set. So right now I just have a data set called cops, and we can assign it to that. We can even run models in here. So if you already have like pre-trained models, or you want to use any of these ones in here, you can use that directly. So it could be like plant disease, run model. You can set up a confidence score and threshold as well. So right now it's running, doing inference on this image here, and then it's going to extract the results. You can both do this for image tagging, for classification, and also bounding boxes. And again, you can just go in and add all the different bounding boxes here directly. You can go in, choose them. You can choose different labels and so on. I showed you that you have the other labels for the mouse before. So this is everything that you have to do. You can even scroll through the different images. So right now you have annotated one image. You can scroll up here to the next one, and then you can create the data set, train your models directly in here as well. So we have our data sets, we have our models, and they also have queries. So you can go in and upload a model, create a new model. You can have TensorFlow and TensorFlow Lite models, so they can run locally on your edge devices. Okay, so now we have a vision model up and running. We have a webcam. You saw how we can actually train the models in here as well, and also like set up our whole data set. So right now, let's just go down, create a new service. Now we can set up our large language model. So we have our chat, LLM, and we're going to add that module directly. Right now, we're just going to call that LLM for the name. And again, these are just the names that you need to specify in the code directly when you're using it. So again, we can go ahead and choose a bunch of different LLMs here. We can go ahead and depend it on the webcam and so on, but we can also set up our configurations directly. So to be able to run the LLMs locally on your own machine, we need to go inside the VM Labs local LLM repository here. And then we have to set that up first of all, but as default, it's going to use tinyLLAMA 1.1 billion parameters. So this is a rather small model, but you can see that we actually get some really good results. And the reason why we're using these small models is, again, we can use this on edge devices. So you can run this on a Raspberry Pi, which is pretty awesome. So we can set up different configurations. You can also test out other different models. So right now we can scroll a bit further down. We also have this Quen model, and then we just need to specify the path to the LLM repo and also the LLM file. So this is an example of how you can use a different model. We can also go and take a look at it here. So this is the Hugging Face model. It integrates with Hugging Face, Roboflow, and so on. So we can just go in, take a large language model from Hugging Face. You can just go inside the models tab, go into the large language models, take one of them, and then you can specify it in this way. So we need the LLM repo and also the LLM file. And that is how you can use your own custom models. But right now, let's just go with the default one, which is tinyLLAMA 1.1 billion parameters. So right now, when we have the LLM set up inside our services, we actually need to copy paste the command, basically just to set up our chat service API. And all of these commands will be down in the description, so you can take them directly. Let's now go inside a terminal and set that up. So we're just going to create a new window, as you guys can see here on the left. So this is the command, pip install chat services API from this GitHub repository from Viam. So I'm just going to hit enter, and then it's going to set up this chat service API, and I'm going to have a code snippet so we can see how we can run these large language models directly inside our Python script. And then we can just copy paste in the code snippet. Again, all of these things will be available on Viam GitHub and also on my GitHub repositories. So all we have to do is, again, set up our connection. So as we did before with our camera and so on, we just need to specify our API key and the ID. And then we also need to set up our robot again, chat from robot. We need to specify the name. So we just called it LLM. And here's the prompt or the query that we just need to throw into our LLM. It will generate the response and we can print it directly. So this is everything that we need to do. Let's go ahead and make sure that it actually did install this chat API interface. And here we go. Now we can see that this is actually installed. We can just close that and we should be good to go. So right now we just need to set up our connection with our API key. We can open up a new terminal inside of our editor. So right now we can just run Python LLM test.py. I'm just going to set up my API key and then we're going to run it. We can try out a bunch of different prompts and see the results from this tinyLLAMA model with only around 1 billion parameters. So let's just run the Python script here. Let's see the results. It's connecting to the socket and we should be good to go. We'll get the response back in just a second. Here we go. Now we got the response back from our prompt. What is a robot? A robot is a mechanical or computer-based device that has the ability to perform tasks and interact with humans in a simulated or real environment and so on. So this is basically the prompt that we're giving it back. So let's see what are the most popular plants. Let's try to give it this prompt here, just another example, just to test out this tinyLLAMA model. After we've done that, we can connect it to the speech interface and connect all the individual components and just make sure, just because we're testing out each individual component, we still have everything combined in the Viam platform with our configurations. So right now we can test individual components, but they're still combined in the backend. So right now here, I don't have access to real-time data. So snake plants, catchy, fan palm. I'm not like too familiar with all of these things here, but again, it's just generating some stuff. If we just summarize this Viam platform, what it can be used for in like deploying real-world application, like the config is pretty much the same, no code regardless of which machine learning framework and also like the model that you're using. You can take out, like swap arbitrary models out. You can test them out with Roboflow, Hugging Face, take whatever model, it doesn't depend on the framework, model, or anything. We just need to have these configurations. You can swap them out directly. So all the APIs are the same regardless of the model because it is gRPC based, so we don't need to take care of that either. And also the SDKs, we have it in multiple languages, so you can use it in a flexible way depending on the project that you're using. You can also combine multiple different programming languages without taking care of anything else than combining it with configurations and on the platforms. So you're going to interact with the models securely from anywhere. You can see everything inside the platform, communicate with it locally, and all of the models, everything is running locally on your own device. Okay, so the last service that we need to connect to it is actually just a speech interface. Then we have our vision model, we have our camera connected, we have our large language model, then we're going to have our speech interface. So let's now go ahead and take this speech interface as well. Let's just scroll down. We have this called speech. We have Speechio. There we go. We can go in and add the module directly. Right now for the name, we're just going to call it speech, and we're going to create our service. Right now, if you just go down the bottom, again, it can depend on the webcam or all the other different components that you have. So let's say that you have a robotics arm. Maybe the speech could be depending on your robotics arm in some way, or all the other components here as well. And all the services are set up in the same way. So again, we just need to copy the speech API service. So I'm just going to take that command. Again, all of it will be down in the description. So if we go inside our command prompt, we're going to open up a new window. And then we just paste this in. So we're going to pip install speech service API. So they have APIs for all the different services. Right now I have shown you for the LLM and also the speech. So let's go in and pip install that. And then we can directly use it inside of our Python code. So if you just go back to that again, it is just all of these APIs that we have up at the top. So we have our chat service API, we have our speech service API, we have our Viam SDK that we installed to start with. And this is basically like how it's built up in different modules and makes it so easy to integrate and connect together. So right now, if you just go inside of it, now we can see that it has been installed. We go back to the Viam platform, we save our configuration, so it sets it up on our server. And now we can go in and connect to it, and then we can talk with our computer. So right now, let's see how we can set up this speech module. I just have this list that we pasted in. So we basically just have to set listen to true, and we can also set up a listen trigger command. And right now it's just hey there, but it can also be like, as you know, hey Siri, hey Google, and so on. So you can pretty much just have your own trigger words here. Now I also need to set up the MIC device name, and then you can basically just get that once you're saving the configuration. You'll get some options in the terminal directly, so you can just go through the logs and you'll be able to see the name of your microphone. So right now I just have a bunch of microphones I've disconnected and have a MacBook microphone, but let's just use the MacBook microphone, MacBook Pro microphone, and we just have to specify that. Again, you can see that from the logs. We hit save config, and then it's going to set that up. Right now I can only have like one microphone connected to the system at a time, or else it won't be able to recognize the voice and also throw it through the large language model. But now we actually have everything. We now go inside our code snippet and go in and open up a new terminal. This is pretty much just a code snippet for running this directly. So right now we're just going to set up our large language model, and we're going to set up our speech from our speech service API that was set up earlier. So this is pretty much everything that we have to do. Again, we have our speech, large language model. While true, we're just going to get the commands from our speech. If our command is greater than 0, we're just going to extract that command, throw that command directly into our large language model. First of all, it's going to take like the trigger word, so hey there, it's going to subtract that, so it's only going to throw in the prompt and what you're actually asking the LLM. Then we can actually just set the output to the response here. We can print the response, but we can also make the text-to-speech module and API here say the actual response out. So right now, we can just try to run this program here. Let's see if we're actually able to do that. So right now, we just run Python test _ speech, but I'll have to disconnect this microphone first of all, and then I'll be able to use my MacBook microphone to capture audio. We will see it in here, and we will also hear the audio. So let's now run the test speech here and see how it works. Hey there.
Hi there. How may I help you today?
So right now we can see that it actually just terminates after that. So it writes, hey there, and then it's basically just going to extract that. We'll throw the command to our large language model. But again, now we're going to set up the whole system, and then we're going to actually ask questions for the specific plant that we're going to use. So right now it's just going to close right after a single command, as we can see here, robot close, but you can wrap your own logic and termination code around that. So now we can see that we have all the components. We have a speech interface. We have our machine learning computer vision model up and running together with the large language model. We're combined everything with these configurations. We have the whole setup. We ran through these example scripts that we have. So now we can run it all. And this is how we can apply machine learning and computer vision models directly on your own computer. So let's now jump into a new Python script. We're combined all of the different kind of like examples that we have. This is the exact same setup as we have been doing for all of them. Now I've just combined them together with some if statements. So we're going to grab up the plant here again. This is the plant that we're going to use. Let's put it in front of the camera and let's try to see if we can get some results. We still have everything running inside the server and also on the Viam platform. So first of all, we just need to have our API, so our chat service API and also our speech service API, and then we'll get like the large language model and also like the computer vision model that we have for our plant. First of all, we have our connect function. Then we can scroll down to the main function once we have connected to it. To start with, we're just going to wait for a connection. We're going to use async to make sure that we actually have the setup and so on, and that we're waiting for the responses for each step. Then we basically just need to give it the robot and also the name of the service or component that we set up on the VM platform. So we have large language model, we have speech, we have our Roboflow plants model, and here we also have a plant, so it's just going to be nothing if we're not able to detect anything. So while true here, we can basically just have a for loop or like while loop running all the time until we'll terminate the program. So right now we're just going to get the detections from our camera. We specify our webcam. So this is the component, webcam camera component that we set up. You can also have like an RTPS stream and so on. We get the detections back here in this variable. We check the length of detection. If it's greater than 0, it means that we have detections. Then we can go inside the detections, take the served element of that and extract the class names. As you recall from earlier in the video, we can also extract the bounding boxes and also the confidence score of our detections. You can also have multiple detections in the model as well. Now we're going to get our speech here. So it's just going to set up our commands. It's going to listen for the voice and we're going to have these trigger words and so on that you saw just a couple of seconds ago. Then we can check the length of the commands here. So if we actually get something from our speech recognition module, then we're going to just take the command, or else if the plant is nothing here, if you're not able to extract the plant, it is just going to throw in this command. So then we're basically just going to have this placeholder here instead for our command. So if we actually detect a plant in the frame, we're actually going to reformat our input to our large language model. So first of all here, we're going to set up our plant, and then we just have this specific format. So we have a consistent format that we throw into our large language models every time. Then we're going to print the command and just throw it into our large language model by calling LLM.chat, throwing the command or like a query and a prompt, and we get the response back. Then we can either like both print this response, but we can also have the module here say it out loud on your speaker. So we can say speech.say, and then we just throw in the response and we set it equal to true. So then we're basically going to close our robot after a single run. You can also put this for another condition. So it could be like if you hit a key on the keyboard, or if you're using some other processing tools for doing something like that inside your program, or if you're processing like multiple frames and so on before you want to close the robot, you can just wrap some logic and code around for that. So right now we have everything. We can just run the program. We're just going to have asyncio.run, and then we just run our main function. So let's go up inside the terminal again, and let's just run it directly. So we have Python plant system, there we go, .py, and we're just going to hold the plant here up front of the camera. Let's try to see if we actually get a response, and then I'll have to disconnect my microphone so I can actually talk to it. And then we'll get the response back right here in the terminal, and we have our whole project built out. How often should I water this plant?
As with all plants, watering a Monstera deliciosa is essential for its growth and overall health.
So that's pretty much it, a wrap for this video here, guys. We have learned how we can set up all these different components with the VM platform. This is pretty cool. Definitely check it out on yourself. You can create some really cool projects and applications in a very short amount of time. So it's a pretty cool project that we have thrown together. We were able to actually create a computer vision model that could detect what type of plant this is, even though I have no idea what it is. So we even tricked the large language model and the vision model as well, because this is a fake plant, as you guys can see. So it doesn't need any water at all. And I hope you guys have learned a ton this video here. Definitely go check it out. This can be used for a lot of cool applications and projects. And then I'll just see you guys in the next video. Until then, happy learning.